Today I'm going to be discussing the X-ray circuitry, and I'm going to be using this diagram that I have drawn to explain it. And if you guys aren't able to see it, then I will submit this image in with the video so then you guys can see it a little better. Alright, so first with the X-ray circuitry, we begin at the plug-in. And the plug-in is just what provides the energy from the wall. So here in the United States, we have about 60 hertz of energy every time we connect something to the wall. So once we plug that in, the electricity is going to go on through. And right off the bat, there's a line monitor. And all the line monitor really does, it reads the voltage that's coming in from the wall. And there's also a line compensator, and that just also reads the voltage and compensates for any fluctuations that there may be in the volt. So all it's doing is maintaining a constant voltage. So if we go back up here, the voltage that's coming in, it's going to go through an auto transformer. And the auto transformer is either going to step up or step down the voltage. So in our case, if we want to step it up, say we want to step it up to 85, it's going to go on through these little loops and it's going to go up. And say we choose 85, the major KVP selector is going to choose the tens place, it's going to choose the eights, and then for the minor KVP selector, that chooses the five or the ones place. And so the electricity go in, there's an exposure timer here, and all that does, it stops the exposure. And there is also a KVP meter, and the KVP meter is just going to estimate what the KVP will be at the very end of this whole circuitry. So next thing, the voltage is going to go through the high voltage step-up transformer. And this is also going to increase the voltage according to the turns ratio. And at this point, once we increase it, it's going to be an alternating current. And for X-ray circuitries to work, we need it to be in direct current. So the way that the X-ray circuitry accomplishes this is by having its voltage go through these little diodes. And the diodes that we typically use are solid state silicon semiconductors. And they go through, and the diodes will rectify the charge, which just means they convert the AC current to DC current. And once all the DC current, all of its DC current, it's going to go on through and go onto the anode. There's also an MA meter here, and the MA meter is just going to measure what the mass is going to be at the end. All right, so if you go back down to the beginning, we're going to go and we're going to look at the filament side of the X-ray circuitry. So the filament side is going to go through the auto transformer again. It's going to come out through the secondary connections, and then it's going to go to the MA selector. And these MA selector is what we kind of control because we get to choose what MA station we want it to be at. So say you want it to be at 300, 400, or 500 MA, you're going to choose whichever MA station you want, and then it's going to go on through. It's going to go through these filament circuit resistors and go down to the filament transformer. And the filament transformer is actually a step-down transformer, so we're going to decrease the voltage, but we're going to increase the current. And we want to increase it to about 12 amps in this case. And then we're either going to choose the large or small filament, depending on if we want to use a large or small focal spot. And then that's going to lead on through to the cathode. So I'm just going to get another diagram that I have drawn. It's a little more in depth of the anode and the cathode to see what's going on. So we're going to continue on with the cathode. So the 12 amps are going to go on through, and they're going to heat up the filament. And when you heat up the filament, electrons start to boil off. So a thermionic emission happens. And there's also an electron cloud that begins to form here. And then there's a focusing cup, and the focusing cup is kind of just like a way to direct the electrons onto the anode. So here we are. We have a lot of electrons here in the cloud just forming. They want to go to the anode. So as soon as we apply the current to the anode, all the electrons are going to go rushing on over to the target. And that's called the tube current. And they could either have perfect interactions. They could go on through, make X-rays, make the photons, and go through the window and interact with our patient. Or they could have other interactions like characteristic or Bremsstrahlung interactions. Or most of the energy could just be lost as heat, and it'll go back into the X-ray circuitry. Well, I hope this video has been helpful, and I will submit these images so you guys can see those as well. Thank you.